All right, 2.4, a library of parent functions. That's what we're talking about. We're talking about the parent functions. We're talking about the parent quadratic, the parent linear, the parent absolute value, the parent. Does this sound familiar? Okay. Parent functions are what can you say about parent functions? What are they? Simple, original. Okay. Most basic, right? Most basic of the functions. So we're going to identify the graphs of linear and squaring functions. Cubic, square root, reciprocal function. What was the reciprocal function? Y equals 1 over x, or reciprocal, right? 1 over x, yeah. Recognize graph. So just by looking at a graph, what is its parent? No big deal. And piecewise, your favorites. Okay. A little more. Specifically the constant ones, like y equals 4. One of the goals is to enable you to recognize the basic shapes of graphs. You know that a linear function y equals ax plus b has a slope m equals a, y-intercept ab. No b there. The graph of the linear function has the following characteristics. The domain is all real numbers. How come the range isn't all real numbers? Well, look at the second bullet. What's that saying? When m is not 0, the range is all real numbers. What happens when m is 0? Okay, you have a horizontal line, right? Is a horizontal line going to have a range of all reals? What's the range of a constant function going to be? That specific constant, right? Y equals 6. What's the range? 6. What's the domain? All real numbers, okay? The intercept occurs at negative b over m, 0. That's the x-intercept. The y-intercept is at 0b. If if the slope is positive, the line is going up, so it has a positive slope. If m is negative, the line's going down. Okay. When m is 0, we have a constant. Write the linear function for which f of 1 equals 3 and f of 4 equals 0. Okay. So I want this equation. What have they given me? 2 points. What are the 2 points? There you go. 1, 3, let's see, and 4, 0. Those are the 2 points they gave me, right? Now they gave it to us in a way that we're not familiar with, but it makes sense. What this is saying is f of x equals 3, meaning if you plug x value of 1 in, the output y is 3. What this is saying. Okay, so it's a coordinate. So if I want the equation of a line that goes to those 2 points, what do we need to do? Find the slope. What's the equation to find the slope? Y equals m2, m equals y2 minus y1 over x2 minus x1, okay? And so given the 2 points, does it matter which one's point 1 or point 2? Okay, does it matter if we're consistent? Yes, right? So just because it's written, I'll just call the one on the left point 1 and the one on the right point 2, which makes my 1 x1, the 3 is y1, the 4 is x2, and the 0 is y2. Plugging our values in gives us y2 is 0 minus y1 is 3 divided by x2 of 4 minus x1 of 1. So my slope is negative 3 over 3, which is negative 1. Okay, great. I have a slope. Now what? Point slope. Okay. So what are we missing to write the equation of the line? What do we need? The y-intercept. We need b, right? So I'm going to work this two different ways. Okay. Y'all said point slope because I have a point and I have a slope, right? Okay. Which point do I use? Does not matter. Okay. Even though the equation says y minus y1 equals m times x minus x1, I can change my mind. I've already called this point to be x1 and y1. But if I want, I can change my mind and use this one. Okay. It doesn't matter. Which one would you rather use? Why? You like the 0? I like the 0 too. So me personally doing it, I would actually take this point and actually plug it in here, okay? So which gives me y minus y1, which is 0, equals m, which is -1, times x minus 4. Distribute the -1, we get y equals -x plus 4. Okay. Now, hopefully, you maybe have these formulas on your cheat sheet, right? That you can use on every test, because every test we take in this class, we actually get to use a cheat sheet. Does everyone understand that we actually do that in this class? Okay, just making sure, just making sure. Another approach to do this is just using y equals mx plus b. Is everybody familiar with that one? So if I took y equals mx plus b, and I said, well, let me just use one of those points. Okay, let's use this point again. I'm gonna take this point and plug it in for, even though it doesn't say y1 and x1, I'm gonna plug that in right there. And I'm gonna take this m value and plug it in right there. If I do that, what's it gonna give me? B. Y'all see that? I will plug in every variable but b so I can solve for that. So the y that I chose to use is 0 equals -1, x is 4, so -4 plus b, which I don't know. Let's get b by itself. Add 4 to both sides. Okay, so now that I know that b is 4 and I know that m is 1, can I take these two values and make my equation? Y equals -x plus 4. Did I get the same thing? Okay. Folks, it's just options. Okay. Whatever you want to do. Any questions on that, on either attempt? Have y'all ever done it this way that I just showed you? A couple of you have? Okay. All right, next slide. It's just the rest of the answer. I had most of the answer covered up. Make sure everything's covered on that slide. Yeah, we're good to go. Do what? Okay, scrolling down. And there's what the graph looks like. Has the negative slopes going down. They don't put arrows on their lines. What did you find out on that homework question? Do you remember? The one that did not have an arrow, it had a dot on one side, and you were finding the domain and the range. There was a homework, I think he's working on this homework assignment, and the graph wasn't this one, but it had an endpoint, but on the other side had nothing. No arrow, no open circle, no closed circle, nothing. Okay, so it's assumed an arrow? Okay, okay. Okay, okay. So no circle means it keeps going. Got it. Linear and scoring functions. There are two special types of linear functions, the constant function and the identity function. The constant function is a horizontal line. The identity function is actually the parent function. What is your own identity? You are your own identity, right? So the identity function, which also happens to be the parent function for linear, is y equals x, meaning you give me an x value and the y value is the same. That's called identity, okay? So just another name for the same thing. That's also the parent function. Domain and range, all real numbers. The graph of the identity function is a line. Each x coordinate equals the corresponding y coordinate. X, the graph is always increasing. There you go. Scoring function looks like a U. It's a quadratic. Quadratics look like U's. The domain, what can x be of the scoring function? What can you plug into here? Any x value that you want, right? So the domain is all real, but notice the range is not. Okay, if we're talking about the parent function, any number that you square can't be negative, right? Can it be 0? 0 squared is 0. That's why the range is all non-negative real numbers. The function is even. What's that mean? If a function is even, it's not odd, correct? What's it mean for a function to be even? Let's think of something. Let's throw something symmetric about what? The y-axis. Okay, if a function can be folded in half on the y-axis and it lays on top of itself, then it's even. Okay. And of course, it only has one intercept, and that intercept is at 0, 0. So for this function, the x and the y-intercept are the same, right? There's only one x-intercept, there's only y-intercept on the parent. Here is a graph of the parent function. Notice from negative infinity to 0, the graph is decreasing. From 0 to infinity, the graph is increasing. It is symmetrical about the y-axis, which is why it's even. It says it has a relative minimum at 0, 0. I can call this specific relative minimum something else. Absolute minimum, right? Okay. Okay. I'm going to sketch a quick graph here. Okay. This right here, this point at the very bottom here, is a relative minimum, which means the points close to it on both sides are higher. So this point right here is a relative minimum. This point right here is also a relative minimum because the points on both sides of it are higher. And this last point is also a relative minimum because both points on both sides of it are higher. However, how is this low point different from the other two low points? This is the absolute lowest, right? So all three of these, that one, I'll actually put dots here, and this one, plural, it's not relative minimums, it's relative minima, but this one right here is special. This is an absolute minimum. Okay, so what would this point right here be called? Relative max. What's this one called? Relative max. Notice the arrows go up forever. That's why I changed the graph to make it go back up again, because it goes up. Does this graph have an absolute maximum? No. Okay, it has no absolute. Does this graph have a relative max? No. Does it have an absolute max? No. Okay, that makes sense. I forgot who asked. Okay, I knew it was one of y'all that asked, what's that even mean? Huh? I don't know what's going on the computers, but I'm seeing some smiles going on, and that's not a good thing. You have your cameras on or something? No, prior to that. Basic characteristics of the cubic, the square root and reciprocal functions. The cubic function, do y'all remember what that one looks like? Oh, no. Okay. Y equals x cubed looks something like this. A what? Okay. Do y'all remember what the square root function looks like? Like, pew, pew. Okay. This is like the Star Wars graph? No. Quit cheating. Right? You can't take the, yeah, this is a pew. It's not a pew pew. All right, Ty, talk to us about what the reciprocal graph looks like. The reciprocal graph is down here and up here. And we're going to see these again. I just wanted to see if y'all remembered, because we've talked about these before. The cubic. Okay, so looking at this cubic, domain is all real, right? I can cube any value, any real number. The range, it goes down forever, it goes up forever. So the range is all reals. It's odd. What's that mean? Correct. What is it symmetric about? The origin. It is symmetric about a point. Okay. And the intercept is at 0, 0. Questions on the cubic function? Okay. There it is. Notice this graph is always increasing, right? Okay. Always going up. Symmetric with respect to the origin. That's why it's odd. Next one. Go. Square root function, domain. What can you take the square root of? Or positive numbers or 0, non-negatives. Okay. So the domain is all non-negative real numbers. The range, all non-negative real numbers. The graph that I drew, it was going up. It started at the origin, didn't it? Okay. Intercept at 0, 0. And the graph is always increasing. Is there any symmetry? Okay. So we don't talk about it being even or odd. Don't talk about it, huh? Okay. So there's the graph of the square root. Next function, the reciprocal function. Notice that on the reciprocal function, it's 1 divided by x. Immediately, what can x not be? What can you not divide by? Can't divide by 0. So just by looking at the function, we know the domain is not 0, right? Not 0. That's not how they wrote it. Okay. Now, I have one item. I'm going to divide it infinitely many times. Will it ever be 0? Theoretically, I could take a candy bar and share it with the entire world. Because theoretically, I can cut it in half and 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 cut it in half. And I would still have candy bar to give to every single person in the world. That is why the range can't be 0. I don't care what number you've got. It's never going to be 0. 1 divided by who cares can't be 0. Okay. The function is odd. It is symmetric about the origin. Obviously, if the domain can't be 0 and the range can't be 0, does it have any intercepts? No. If it can't touch the x or the y axis, you have no intercepts. It's decreasing from negative infinity to 0 and from 0 to infinity. The graph is symmetric with respect to the origin. Didn't it say that twice? I don't know why they go about this. These two things mean the same, don't they? They mean the exact same thing. Just keep saying it over and over and over. And here's the pew-pew graph. Right. Oh. Right. And here are parent functions. Just a quick shot. You have your constant. You have your linear. Then they throw in the absolute value for the heck of it. Right? What's the domain of the absolute value? All real. What's the range? Yeah. Y is greater than or equal to 0. Yep. Okay. Well, the properties for absolute value and the squaring function are pretty much the same, aren't they? Think about it. They have the same symmetry. They have the same domain. They have the same range. They have the same intercepts. They have the same area of increasing. They have the same area of decreasing. They're both even, symmetric. Huh? Yeah. Okay, but a lot of the same properties. Okay. There's your quadratic function, your cubic function, and your reciprocal function. So know the basic shapes. Okay. We can manipulate those. We can translate them. We can do all kinds of movement. And the parent figure, if you will, is still there. Piecewise. A piecewise defined function is a function whose domain is divided into pieces, hence the name. Okay. By looking at the definition of a piecewise function, they are telling you the domain. Okay. So looking at this graph, what's the domain? What can x be? All real numbers, right? If the number is -6, which piece does -6 apply to? The top one, because it says x is less than or equal to -6. Where would -12 be? The top one. No. Yeah, -12 is the top one. Is it all real numbers? Is the domain all real numbers? Look again. What's the domain? Where's the domain start? Until? Okay. I'm kind of wondering right now if that's by chance an error when they're doing this. So what would this look like? Okay, it just says sketch. I'm going to make it a very, very rough sketch. Let's look at this first piece here. What's that look like? Okay, so a line that intercepts here, but not really, because it doesn't exist here. What's the slope? 1. I'm just going to kind of do a slope of 1, and I'm going to come back to about where I think -6 might be. Something like this. The other side. Down to -4. 1, 2, 3, 4. Little flatter. Okay, so it's a little flatter, but it doesn't start until we get to 6, which is going to be negative, right? Because you plug a 6 in, you get half a 6, which is 3. 3 minus 4 is -1. So an open circle. Something like this. So this is a very, very rough sketch of this graph. And by very rough, I mean very, very rough. Okay. Remember when we graphed these, I said, okay, let's ignore that and just graph the line, right? And then you would graph the line on your graph paper and then erase, right? And then all I had to remember is, open circle, close circle. Questions on this guy? Okay. There you go.